Hello, my name is Kevin Kine, and today I'll be showing you a demo of how to write to flash memory using the MSP432. And I'll start by giving you a level 0, level 1 UML diagram, going through a code inspection, and then finally giving you the actual demo. So let's get started. Here you can see my level 0 diagram of what we'll be doing. So we have 3 inputs. Button switch, watchdog timer, and power. Button switch will just allow our user to reset the system if they would like. Watchdog timer, make sure that we don't get caught up while we're actually doing our flash memory writing. And USB power, obviously, power our board. 2 outputs will be green and red LEDs. Green LED will allow the user to see that the flash memory is successfully written, and the red LED indicates a reset of the system. Okay, moving on to our level 1 diagram. We have four different modules here. Our switch input subsystem, which has our input of our button switch. This allows the user to reset the system, so the user pushes down the button. It'll send that to a main module, telling it that the button's been pressed and held. And this will actually end up timing out the watchdog timer, in which we can move on by looking at our watchdog timer controller module. We have 2 inputs of enable and clear counter. The enable input just starts the watchdog timer, and the clear counter input clears the watchdog timer to prevent it from timing out. And we have 1 output of the watchdog timer controller, which is the reset system, and that tells our main module to reset, to actually reset the system. And finally, our LED output subsystem. We have 2 inputs that come from our main memory controller, which these tell the LED output subsystem which LED to turn on, and the 2 outputs of that are actually to turn on the appropriate LED. So if we move on to our UML diagram, you can see our basic UML diagram. We begin, halt the watchdog timer, initialize our ports. We're going to flash the red LED just to show that we're rebooting or starting up our program. And then we initialize and begin our watchdog timer to make sure that finally we're going to go through our memory to actually write our memory sequence. So we have to unprotect our memory sector, erase what's there, write the information we want to, and then reprotect the memory sector, update our memory location, and then flash a green light for 1 second. And if that works, we're going to go back and continually rewrite the flash memory. So now I'll give you a quick code sample of what we'll be doing. Okay, so here you can see my main function. So we begin by halting our watchdog timer, and then we're going to initialize our ports, which you can see here. Our ports, our port pin 1.0 will be a red LED. Port pin 1.4 is going to be our switch 2, and port pin 2.1 is going to be the green LED. Okay, so now that our ports are initialized, we're going to flash our red LED just to show that we began to boot up, and this will occur if we either cause a reset or the first time we boot up. This data value is going to be the value that we're going to be putting into the flash memory at every location. And then this section here shows us the initialization of our watchdog timer. So we're setting it to the source SM clock, about 8K clock iterations. This is going to lead to about a 4-second timeout. We're going to do a soft reset of our system if we do reach that timeout, and then we actually go ahead and begin our timer. And then throughout this, we're going to be checking to see if the user's holding down the button. If so, we're going to stop doing stuff and actually reset our system. This sector array is just a way of keeping all of the sector locations in one array to make it easier. This is just going to make the for loop that we're using later look a lot nicer. So that's what this is. And then this while loop is where all the magic happens, where we actually write our flash memory. So here you can see I set my destination to the first spot of sector 0 of bank 1 in our main flash memory. And we have a sector size data array, and in that we're going to set the data value that we set previously. to every spot in that data array, and then we're going to actually write to our flash memory here in this for loop. So, and throughout all this, I just want to point out that you can see that we're clearing the timer just to make sure that we don't cause an unwanted reset in our watchdog timer. Okay, so in our for loop, again, we're listening to make sure that our user is not resetting, clicking and holding that switch 2 to reset the system, but our flash, we're unprotecting a sector using bank 1 and whichever sector we're in, and we'll go through this 32 times to make sure we hit every sector. We're going to erase what's in that sector, program in our data to that destination, which I have set up here, and this is the size of the data, which again is going to be the same as our data array. And then finally, after we write, we're going to reprotect that sector to make sure we don't accidentally erase what we just programmed in. And then we have to update our destination pointer, so we just update it by the length of one sector, which again is 4K, which you can see here. And if all of this works and we go through 32 times with our flash sector, we're going to flash our green LED. And if we do get stuck in here, if one of these happens to not work, it's going to get caught in a no operation function, which will cause the watchdog timer to time out on its own, and that will cause the green LED to not turn on, and you will see that it was unsuccessful that way. So now I'll give you a demo of how this actually works. I'm going to debug. I'll show you it compiling. Okay. Alright, so here you can see my board is ready to go, just waiting for me to run the program. And I'll go ahead and do that now. In the program, you see the red flash to show that we had booted up, and that was the boot up red flash. And now you can see that our green LED is actually flashing, showing that we were successfully writing to memory. And I'll show you a reset. If we hold down switch 2, you can see it stopped, and we'll get the red LED to turn on, showing that we reset our system. So the user keeps holding down and it'll keep resetting, and then once you release, it'll start to write to flash again, and you can see that it's successfully writing because of that green LED is continuously coming on. So yeah, thank you very much for watching. We went through showing our level 0, level 1 and UML diagrams, did a code review, and showed you a live demo of the MSP432 writing to flash main memory. Hope you enjoyed it. Thanks for watching.